Hi everybody, today we're looking at triangles and we're going to see how that fits together with our existing knowledge of polygons. So, triangles are a polygon and they're a polygon with three sides. They can be named either by their side or their angle. So let's look at sides first. So if all the sides are different lengths denoted by these lines on the edges themselves, we call this a scalene triangle. A scalene triangle has no equal sides. An isosceles triangle has two equal sides. This length is the same as this length. The base length doesn't have to be the same. The angle where the vertex where the two equal sides meet is called the apex, and the angles at the bottom are called the base angles. We'll find out why that's important later. So an equilateral triangle is equiangular. All the angles inside are the same, and all the lengths on the outside, more importantly for naming, are also equal. And funnily enough, the angles are also 60 degrees. So that's one way to name a triangle, by its sides. We could also name a triangle by its angles. So if all the angles are less than 90 degrees, we call it acute. If one of the angles is exactly 90 degrees, we call it a right triangle. And if one of the angles is bigger than 90 degrees, we call it an obtuse triangle, because it has an obtuse angle. Right, so some properties that we have of triangles. The internal angles, this one plus this one plus this one, always add up to 180 degrees, and we use that quite a lot. And as I said earlier, an equilateral triangle is also equiangular. All the angles inside are 60 degrees. The base angles of an isosceles triangle are equal. So if we go back up here, these two angles here are at the base, not the apex angle. The other two angles are equal. And if we take the apex angle away from 180 degrees and then halve it, we'll get the size of the two base angles. And that's what this says here. Half of 180, take the angle at the apex. Now the exterior angle of a triangle is supplementary to its adjacent angle. So let's draw an exterior angle, because I haven't got one here. Here is a triangle. Oops, that's not very well drawn. Let's try again. It's a bit better. So if this was 20 and this was 50, that's not, let's not make it 90 because it doesn't really look like 90. Let's make it 30. Okay. No, let's make it 60. That'd be better. No, let's make it 100. There we go, now I'm happy. Okay, if this was 20 and this was 100, that would be 120 degrees so far, leaving 60 degrees to put here. Now, because this is along a straight line, the other angle must be 120 degrees. 60 plus 120 gives us 180, which is the property of a straight angle. So, the exterior angle, this one, of a triangle is supplementary to its adjacent angle. Adjacent means next to. The angle that it's next to is supplementary. Tells us that that one is 120 degrees. Now, we may look at exterior angles later because it's got some additional properties, but that will do for now. So, let's have a look at these in some examples. Example 1, we have a triangle. This is 60. This is 35. Well, if that's 35, this hasn't been done correctly. Meaning that to find the remaining angle, we're going to have to use the property angles in a triangle add to 180 degrees. And we should always give a reason why we're writing down some numbers. So theta is going to equal 180 minus the 60 minus the 35. That's 95. 95 from 180 will be, what's that, 75? 75 plus 95 is 180? Yes. No. 75 plus 105 is 180. So what have I done? It's more than that. So I have 95. It'll be 85 degrees. There we go. First one done. Second one, we have a right angle triangle. So we have 90 plus 30 is 120, 120 from 80 is 60. The property that we've used is angles in a triangle add to 180 degrees. That plus that plus that must be 180. If that plus that is 120, that must be 60. So this one we've got to use some other properties. We have an isosceles triangle here, meaning that these two angles here are equal. We know that the angle at the apex is 20 degrees, leaving 160 degrees. If we halve 160 degrees, we get 80 degrees, which will give us this angle here. So here's where we've done it. We've said, let's find out the remaining angles. 180 take 20 is 160. Divide that by 2 will give us 80. And the properties we've used is angles in a triangle add to 180 degrees, and the base angles in an isosceles triangle are equal. And that's why this works. Last one. This is an exterior angle problem. So we'll start with finding this unknown here before we can find the angle that we're actually after. So in our case, x is equal to 180 take 50, which is definitely not 50. So we better fix that up. 180 take 50 is 130. And then if we finish the sum, 180 take 130 is 50 degrees. Now, as you can see, our diagram is terribly out of scale because that doesn't look like 130 degrees, and that certainly doesn't look like 50. But you get the idea. And it's not uncommon to be given a triangle that's not to scale. They're probably not as misleading as that one. So I hope that was helpful, and I will see you for the next one. Thank you.